So they say, Kochi, Pazhaya Kochi alla. But I'm back for another round. Hallucinations, latency, high token cost, I don't like. But AWS UG Kochi, I like. Hello everyone, my name is Aparajithan. I go by Apar. I'm a Principal Enterprise Solutions Architect at AWS. I've been with AWS for 4 years now. Prior to that, I used to lead product development teams in multiple companies. And fantastic crowd, love being here. AWS UG Kochi almost seems like family to me, so I can never say no to them when they ask me to come and present. So today we're going to have a very interesting session, and I don't want this to be just me giving you, a lecture on this. Let's make it very interactive as well. I hope we picked something very interesting, something a bit generic, so that it will sort of, you'll also, we'll start from level 100, we'll get to level 300 if possible, if we have time as well. So essentially the idea is, you hear a lot about agents, you'll hear a lot about agentic AI. So how does it really work? What does it really take for you to just doing something in your MacBook or your laptop to really running something at production scale, okay? So we're gonna together, we're gonna see from 0 to 100 how to do it. And hopefully we'll have enough time for Q&A so that if you have any questions, there are no dumb questions, ask me. That there can be some dumb answers, you have to be okay with that. All right, shall we get started? I didn't hear you. Great. Okay, so what are we going to do today? First, we're going to see how, the evolution of how we arrived at the multi-agent system so far. I think Ananya touched upon a few of that, so I'm not going to repeat some of the things that she already said. We're going to get into some of the core concepts. What really makes a system truly agentic? We're going to just talk a little bit about React. How many of you know React? Not the React UI, the React approach of LLMs and agents. Okay, I see one hand. All right, so we'll get into the foundations of the React, which is basically the agentic loop. Then we'll put together an architecture for some of the multi-agent patterns, so that you take home with some understanding of what are the design patterns and architectural patterns for building multi-agent systems. And we get into Bedrock AgentCore, which is what is the platform, AWS's platform for you to build production-grade generative AI and agentic applications. And then we'll see how can you build your first multi-agent systems. Okay, so this is going to be our agenda today. Excited? Awesome. All right, so Ananya covered this, so we're not going to spend much time here, but essentially, with the GenAI, when we started this, it was a simple chatbot, right? So these GenAI chatbots, they don't have memory, they don't have contextual relevance. So essentially, any prompt that you provide, the LLM basically provides you a response, and we started from there. Then we started building generative AI agents, right? So the agents started having memory, long-term memory, short-term memory. They had context. They had tools through function calling. They had access to databases through retrieval-augmented generation. So essentially, the agents were, the generative agent was small. But where we are right now is agentic AI systems. So the difference here is that agentic AI systems can solve really complex problems, okay? They can decompose the problems into tasks. They can autonomously execute tasks. They can aggregate the response and provide you a very cohesive answer, almost emulating human-like thought process, right? So this is where we are right now. So if you see at the far left, there is more human oversight required. As we are today, as I speak here, the agentic AI systems have become so mature that they require very less human oversight. It's not completely avoidable, but still much lesser than what it used to be compared to last time. Cool. So what's the issue with a single agent? First of all, when you have a single agent that does everything, just like any typical monolithic architecture, right? You have a single point of failure. Not just that, let's say if you're building a, let's say, booking agent, then there are multiple things that happens in booking, right? First, you have to search for availability of flights and hotels. Then you have to look at the user's preferences. then you have to, schedule, then you have to do the payment, then you have to do the booking. So there are too many things. Then if you just have one agent do it all, first of all, you're going to overload that agent with too many prompt complex instructions so that the agent gets confused. Then it's going to be more overhead to manage that agent. So essentially, the scope of what one agent can do gets limited. And whenever you think I'm just going or you don't understand, just raise your hand. I'm going to be here all day, so you can always grab a coffee and we can talk about it if you want to get more into the depth. Second is reliability issues. So as these complex become more, as these tasks become more complex, a single agent system can start hallucinate because it's now processing too much information and too much instructions. So essentially, right, there is no specialization, right? I mean, you're asking the one agent to basically do everything to sort of become God of all things. So because of lack of specializations, it tends to just wear off when it's not able to get the context loaded. Scaling challenges, right? So if you have one agent, then how are you going to scale it as the more users start accessing it? So you can't parallelize the reasoning, and that's another limitations with a single agent system. So the solution is just like how we started, breaking down complex systems, monolithic systems into microservices. We start breaking down these complex tasks into multiple agents. So that's where we are. So let's start with, spend a little bit of time going through the agentic AI fundamentals, right? So what is really agentic? I mean, have you ever asked the question, what does this agentic mean? So look at traditional AI. I can't believe we are saying traditional AI. I mean, come on, this was just a year ago, right? Amazing how fast the AI field is evolving. First is the traditional AI, which it just responds to prompts. And usually, it's a single-turn interaction. You ask a question, you get a response. It's a request-response model. It doesn't really remember your previous conversations. It doesn't really remember the context. And it always requires a human in the loop because because of the non-deterministic nature of the LLMs, anytime you ask a question, you may not get the same or similar response. So always a human is required to validate that. Now you look at the agentic AI. First of all, you can pursue these goals asynchronously and autonomously, right? Once you've broken down the task, and don't worry if this doesn't make a lot of sense, we're going to get into the details, right? It's multi-step reasoning. So it's not like you provide an instruction or you provide a prompt, and then the LLM just gives you one response. There's actually an agentic loop that happens, which we're going to see next, how it works. So there is a multi-step reasoning process involved. There is a contextual memory and context retention with a multi-agent system, with the agentic AI system. And the agentic AI knows that when it's not able to respond or when it's not able to solve a problem, so it knows when to reach out to a human for support and help. Is it clear, the difference between a traditional AI and agentic AI? Clear? Good. I see some heads nodding, some heads are like, All right, agentic loop. All right, so this is pretty interesting. First, perceive, right? This is the part where the agent starts getting the information through prompts, user prompts, system instructions, maybe output of your tools, or the previous context conversations, right? It starts gathering information. So this particular step is called perceive. The LLM is trying to understand the scope of the problem. Second, reason. Then it starts thinking. So this is where the LLM kicks in. It starts looking at it's looking at the inference and say, okay, what do I do now? How do I decide? Who do I delegate this to? What is the right agent for me to delegate this particular task and get it done? Which tool should I invoke? Which RAG, which database should I get this information? So it starts to now reason about it. So once it's done, it starts acting upon it, right? It knows, okay, in order for me to do booking, I need to first get the user's profile. So I'm going to have to invoke this agent which has the user database, right? So then it starts acting upon it. Lastly, it starts observing. So it gets the information through RAG, through APIs, through MCP, whatever, right? And it finds out, do I have enough information? Can I go ahead and respond? No, I don't. So I'm going to again have to go back to the perceive. So that's why this is called a loop. So because the loop keeps going until there is an exit condition. There could be multiple exit conditions, right? One is the LLM got the response that it needed. Second is it maxed out the number of retries. Third, there is an error condition. Fourth, you're running out of tokens, right? So there could be multiple exit points for when the loop actually would break. Okay, so this is really important, guys. So let's just spend a little bit of time on this, right? So this is the whole foundation of how the React workflow works. So basically, React is nothing fancy. It just means reasoning and acting, right? Which is basically the core pattern that's behind the modern AI agents. So let's take it with an example, right? First, it starts reasoning, then it starts acting, then it's observing, then it's repeating. This is what we saw in the last slide. So let's put it through an example here. So let's say that you have an agent that is looking up your order. So in the thought process, first it says, okay, I need to find this user's order status. It figures out that it needs to retrieve the order status. So what's the action? It's basically calling an API to get the order ID. Then it's starting to observe. It says, okay, it says order has been shipped, and this is a tracking ID. But this is interesting, right? Now again, there's a thought. Now I should get the delivery estimate. Because the use case is, what is the order status? Getting the order ID and getting the order shipped is not a status, right? It needs to have more contextual information upon it. Then the next step is it calls the API, get tracking ID for that particular order. Then it's observing, it's thinking, okay, it says that this particular order has been shipped by Blue Dot or DTDC and it's going to arrive by 5 p.m. tomorrow. Then now the agent exits, the loop exits because it has all the information and it responds to the user saying, your order will arrive by 5 p.m. tomorrow, right? You see there is no order ID here, there is no tracking ID here, it's just plain natural language response back to the user, and that's how this agent is good. So I hope the agentic loop is clear. Raise a show of hands. I hope the React foundation is clear. Fantastic. Let's go. All right, so multi-agent system, right? We're getting into the level 300 now, folks. So stay with me. So what is the multi-agent system? So this is where we do divide and conquer, right? How this is going to work. First, you're going to have a supervisor agent. But the supervisor agent doesn't do the work. The super agent knows about the specialized domain agents. Which agent has what capabilities? It has the ability to sort of reason the context and find out what needs to be done. It has the ability to aggregate the response and respond back to the user. It has the ability to, it has the index to look up who does what, which tools have access. But it does not get into the specializations, right? That is where it gets into the delegation. Now you have, let's take an example of a booking system. So you have a flight agent, which does the search and compare. You have a hotel agent for accommodations. You have a policy agent for rule validations. And finally, you have the payment agent for any transactions, right? So if you see here how we have broken down a multi-agent system, every agent is focused. Every agent is testable, independently scalable, independently versionable, right? You're breaking down this monolithic. It's not very different from how we used to do the microservices, right? It's basically just give single responsibility principle and provide the tools and instructions for each agent to scale and evolve independently. Clear? This doesn't sound very complicated, right? It's pretty straightforward. Yeah, well, that's how it is. All right, so this is a classic 3-tier architecture which we all love and are familiar with. First, the orchestrator layer, which does the task routing, workflow management, has the knowledge of what the specialized agents do. Then you have the specialized agents, which are the domain experts. They are the ones who actually carry out the task. And at the tier 3, you have the tools and data. So you have the database, which has your business domain data. It has the MCP server, it has the tool usage, it has the A2A. Don't worry if this sounds Greek and Latin, we'll get into it. So the knowledge bases, so on and so forth. So this is how the multi-agentic system architecture works, top-down. Clear? Clear? Awesome. All right. Okay, so what are some of the orchestration patterns we have? All right, we have several patterns here, just like how you're all tech folks, you know design patterns, right? Similarly, there are some orchestration patterns for agentic AI as well. So first is sequential pattern, right? Essentially, it's about agent. You have agents calling agent, like Karthik calling Karthik, right? To get the workflow. Can you think of in your own problem space where a sequential pattern might become relevant? Can you give me an example? When would a sequential pattern become relevant? Process? Fantastic. Perfect example. But can you apply to a business problem? Okay, brainstorming, but then it's more for something that's more rigid and clear process, right? For example, entity extraction or document processing, right? Where you have to do step 1 and then step 2 and then step 3, right? So here, what is going to be the cumulative latency? Is it, what is going to be the time taken? It's a sum total of the latency of each of the agent, right? Because you can't have one, everything has to work in a sequence. Otherwise, you don't have an output. So that's basically the sequential pattern here. So here you have to be mindful of the latency of each of these agents. The second pattern is something that's more to what you said. Parallel pattern, right? Essentially, for independent tasks. Let's say if I'm doing research, right? Let's say I'm doing pharma research. So we recently worked with a very large GSI, GCC customer, and we, in the pharma business use case, and we built an agent or a multi-agent system where each of these agents would go and research TAVI, it would research web, it would research USPTO, et cetera, aggregate the responses and come back with the result. So essentially, in a parallel pattern is when you want to do something research or something where each agent can execute the task in parallel. So here, what is the overall latency here? Any thought? It is going to be the latency of the exactly, perfect. All right, so third one, hierarchical pattern. So can you think of when this might become more relevant? So hierarchical pattern is you have a supervisor pattern, which we saw last time, and then you're going to have some domain experts, right? But here's the key part, that in the hierarchical pattern, the domain expert need not just be a single agent. So it's very important, right? Because the domain expert can also be a multi-agentic system with its own supervisor pattern and multiple sub-agents. So essentially, in a hierarchical pattern, you're creating that's sort of like a house. But then be careful because you don't overcomplicate it. So essentially, that's the idea. You have a supervisor, you have a sub-orchestration. That's why it's called sub-orchestration. It's not referred to as agents. And it's for fairly complex domains. Maybe you can think about how this can apply to in your business use case. Maybe we can brainstorm later. And the last one is feedback loop pattern. So it's about the agent working autonomously, and then you have an evaluator. Any idea of what could be an evaluator? What does an evaluator mean? Why do you need an evaluator? Exactly. So the point is, see, LLM is still an LLM, right? It is still non-deterministic. So you need to put some guardrails, you need to put some things around, entities around it to make sure that you are actually, the response is consistent with the outcome that you're expecting from an agentic system. So evaluator, these days, LLM as a judge is a very popular evaluator, right? So you have the evaluator will basically say, is it within the guardrails or outside? Then based on that, it will be a pass or a fail. So these are some of the architecture patterns for orchestrating your multi-agent systems. Clear? Any questions so far? Or we'll get to that at the end. Okay, how much time do I have? About 10 more minutes. Cool, we're doing okay. So native multi-agent collaboration. Is it okay? Can we go 5 more minutes? Five more minutes? Okay, cool. So native multi-agent collaboration. So we'll skip this fast. Essentially, you have a supervisor, you have multiple agent collaborators. So you define these roles in natural language. So all the prompts and system instructions you provide in natural language. Each of these agents has full capabilities. What does it mean, full capabilities? It means it has access to tools, it has access to MCP servers, it has access to retrieval augmented generation, knowledge bases, so on and so forth. Essentially, the supervisor agent is responsible for creating the plans and routing requests, aggregating response, and responding back to the user. Okay, cool. Now we arrive at the AgentCore. So what is AgentCore? Bedrock AgentCore. So Bedrock AgentCore is where you build, deploy, and operate agents at scale with any framework or any models. This is really important, folks. We're not saying that with AWS, as Ananya mentioned, right? Our idea is we want to democratize generative AI and put AI in the hands of all the developers and business users, which means that we are not going to restrict you to just using AWS alone. So you can use your favorite framework, right? LangChain, LangGraph, Crew.ai, whatever it is that whichever agent you build, whatever large language model you use. OpenAI, bring it. Gemini, go ahead. If you like Anthropic Claude, do it. Or Nova, fantastic. So it supports all LLMs, it supports all frameworks. The idea is to let you go from POC to hitting production fast as you can. So that's the value proposition of AgentCore. All right. So what is the issue with the prototype to production chasm? Excuse me. First, in a POC, you are very delighted to show that you in your MacBook with 24 GB RAM and GPU, you have something working, and then you show it to your leadership team that they're super excited and they're like, when can we go live and when can we monetize it? And here are some of the concerns and challenges that you will have to be mindful about as you embark on production. First, performance, right? Something that works with a latency for one user may not work for 100,000 or a million users. So you need to have a runtime that supports and scales your usage. Second, scalability. As we saw previously, some of these multi-agentic systems can evolve, scale, and run in parallel, which means that you need to have a platform that allows you to independently scale without you having to do a lot of undifferentiated heavy lifting in terms of setting up infrastructure. Third, security. When something runs in your laptop, you have absolutely probably no security at all. But in production systems, you need to be really mindful of things, right? For example, any APIs or third-party systems that you connect to, it's all coming with multiple usernames and passwords, or API access keys, or IAM authentication, or OAuth, or OIDC, SAML, etc., right? And you have to suddenly, from writing a very fun GenAI agentic program, you are now working on how do I integrate with a third-party IAM system, IDP system, right? Not fun. But important. Then governance, right? Suddenly when you get a call from your IT department saying, what is this? I'm seeing PII code all over the place. You can't have people's private sensitive information like age or name or date of birth or social security or license number. So you need to have an ability to make sure that your governance frameworks are all built in place. Now, can you think of, are you getting the idea? Something that works in a very limited scope compared to what it really takes to deliver an enterprise-grade application. So this is where the challenge is in moving a POC to production. So before we get into AgentCore, this is a nice slide where just gives you a brief, just tells you how Bedrock AgentCore is positioned, right? So I'm sure you would have seen this before. At the bottom, we have Amazon SageMaker, which gives you the nuts and bolts of what to build or fine-tune or train large language models or machine learning models. We also have Compute, where we provide you the industry's best chipsets, whether it's NVIDIA, Trainium, or inferentia to train and deploy your large language models. Then in the middle, we have this agent development software and services, which is mostly the Bedrock. So in the Bedrock, you have access to third-party models. You have capabilities like guardrails and knowledge bases and agents. You have, at the top, you have the managed applications like Q, Quick, Suite, Marketplace, AWS Transform, Connect. And then you have the frontier agents with Kiro, DevOps agent, and AWS security agents. So AgentCore fits right in the middle part, where it helps you to build and scale agents on Amazon Bedrock, on AWS. Clear? Understood where it's positioned? Clear. Let's go on. So these are some of the building blocks of AgentCore, right? We'll not get into each of this, but think of it. Runtime is what allows your agent. It could be a Strands agent that Ananya talked about, which is AWS's open source version of agents. Or you can build your crew.ai agent, or you can bring in any third party or open source agent. So it allows you to, it provides access to runtime. Memory for long-term memory and short-term memory. You have identity for centralized integration. So this is the best part, right? Whether you're doing SAML integration or IDP, OAuth, etc., we give you all the bells and whistles for you to quickly configure and connect securely to your third-party tools and databases so that you can be up and running. So you don't have to do a lot of boilerplate code or configuration. Gateway, which allows you to convert any Lambda function or any existing compute or API into an MCP server, so that can be turn your agent into quickly an MCP-capable tool as well. You have code interpreter, which means that you can create sandboxes securely in a session scope and execute some Python code and then bring back the results. We also have browser, so if you want to do some browser-based tasks, so we support browser. Observability, policy management and evaluation. So these are some of the latest reInvent announcements that are currently in preview. So this is how the architecture of AgentCore looks like. So essentially, your application, you bring any model, you bring any agent, and your agents can talk to each other with A2A, agent-to-agent communication protocol. With runtime, we support any framework with prompts, tools, and context. Access to tools is provided through gateway, through MCP server, and you have policy and identity at the top. You have access to browser tools and code interpreter. And then we support OTel, which is open telemetry. So you have your observability and evaluations. So this is the overall positioning of Bedrock AgentCore. Clear? Cool. All right, so with essentially, with AgentCore, you have framework agnostic, bring your own framework. Session isolation, so each agent has a dedicated micro VM per user session that gets destroyed once the session is completed. You have support for MCP and A2A protocols. That is basically the current latest industry supported. You can go up to 8 hours for very complex. 8 hours is a lot of time for an agent. And I think the way we are seeing that this is going to get increased. So as agents gets more and more complex, they will also require more time to execute, but we support up to 8 hours. And it's completely serverless, and the consumption is, you're charged for consumption based. There's no idle charges, so it's basically pay per use. Okay, so we are at the last part. Woohoo. All right, so how do you build an agent after this, right? After this session, you're going to be like, yeah, I'm going to build an agent system. How do you do it? First, define your problem domain. What is the problem you're trying to solve? Is it a complex problem that requires multiple agents? Sometimes when I talk to my customers, I know that their problem is not even an agentic problem. Something that can be automated with a simple shell script. So it's like a hammer and nail, right? When you have a hammer in hand, everything looks like a nail, right? So try to understand what is the problem you're trying to solve and whether it really requires a agentic solution. So don't try to create 20 agents at the beginning. You're going to be running into a lot of complexity and maintainability issues. Start with identifying few distinct agents with clear identified responsibilities. And think about the orchestration architecture that I talked about. You want it sequential, you want it in parallel, it has to be hierarchical. Think about how you want this orchestration to do. I stop or? I'll close quickly. So set the baseline. So what is acceptable accuracy? What is the contextual relevance? Think about all those responsible AI and guardrails. And make sure that your policies are implemented before you go live. Don't take security and governance for granted. Yeah. So we'll skip that. So how do you go from here? Start with POC. Look at the quality with automated evaluations. Define an accuracy percentage. Implement governance. And in month 4, you will be hitting production. So key takeaways. First, multi-agent system solves that problems that single agents can't. So it depends upon the complexity. Bedrock AgentCore provides native orchestration, memory, policy, and multiple other tools so that you can hit the ground running. Cache the hallucinations and the grounding and other contextual relevance and other metrics before you go to production. Ensure that policy controls stay within the governance bounds. And start simple, don't complicate it unless you need to get to that part. So your next steps, here's some documentation. So please use this QR code to get started with Bedrock AgentCore. With that, I don't know if we have time for questions, but I'll be happy to answer 1 or 2, time permitting. Was this useful? Sorry? Yeah, sure. Yeah.
Something I found which is not there, or probably I missed it, is something like an low-code, no-code agent builder, something like an N8N or a Make alternative. So is it that AWS is not going in that direction, or is it something in the backlog, or you're building it?
Yeah, great question. So the Bedrock AgentCore is essentially for you to build and deploy agents through code. So if you want to do through configuration, we still support the Bedrock agents. So if you see the Bedrock agents, which is the original agents before Strands came in, that is basically a configuration-driven agent. So that is one way. I don't know if you're familiar with Quick. Do we have any session on Quick today? Quick Suite? So you will get to know more. Please do stick around for that session. Quick is essentially what you're looking for. You can create agents, you can create workflows through Quick in a no-code, low-code way. And you can connect to any data sources, and you can get, or any MCP server and hit the ground running. So that is essentially what you're looking for. It's a complete no-code, or it's not even low-code, it's no-code way of agentic workflow development, specifically for the enterprises. Clear? Any other questions? But I'll be here, so we can chat with the coffee, etc. No questions? Wow.
Maybe they're shy. Huh? So maybe they'll find you later.
Yeah.
Cool. Can we have a loud round of applause for Apar, please? Apar, please stay on stage. I'd like